This video is about the quotient of powers property for exponents. And I know all these property names all sound the same, and rest assured that I don't care which ones, if you know which title goes with which, I just care that you can use them. Okay, so let's look at the quotient of powers property. That simply says when dividing variables with exponents, if they have the same base, you can subtract the exponents. And here's what it looks like. If we show it kind of the long way, how it works, if we have x to the 7th over x to the 4th, that means we have 7 x's right here. 1, 2, 3, 4, 5, 6. Very funny. How about if I add another one? Then, if we have it over x to the 4th, we have 1, 2, 3, 4 x's. All this means is that we can say these will cancel. Oh, I kind of screwed it up there. Let me quick fix that. Those x's will cancel. Then these would cancel. And these would cancel. And these would cancel, leaving us with x times x times x, or x to the 3rd. This simply shows us that x to the 7th over x to the 4th is the same as x to the 7 minus 4, or x to the 3rd. Let's try a few more. Don't forget that if you have a plain x, that is the same as having x to the 1. So if we look at this again the long way, a little more complicated problem, I have x squared over x and y to the 6th over y to the 3rd. That simply says if we were going to do this the long way, we have 2 x's on top and 1 on bottom. We have 6 y's on top and 3 on bottom. So I would be able to very simply cancel these x's. Then I have a bunch of y's here that will cancel. There's 1, there's 2, there's 3. So what are we left with? We have 1x on the top, and we have 3 y's on the top. Everything on the bottom is gone, and it should be gone. Now, mind you, we're not talking about negative exponents here. If you end up with a negative, we like our answers to always be positive, but this is just to work on the quotient of powers, and we'll talk about negative exponents later. So here, if we use our property instead of doing it the long way, which could get very long for longer problems, we can say that x squared over x is x to the 2 minus 1. Don't forget, this x has a 1, so it's 2 minus 1. That is 1. So here we have x to the 1, or x. And y to the 6 over y to the 3rd is y to the 6 minus 3, which leaves us with y to the 3rd. So we have x, y to the 3rd. That's our final answer. We can't simplify it anymore. So here are some examples. I want you to give it a try. Don't forget that if you have 20 over 5, you have to simplify that. 20 over 5 equals 4. Don't forget, anytime you have whole numbers, it's just like fractions. You have to do the regular division for this one too. So go ahead and pause the video, and then we will go over the answers. Pause now. Okay, here are the answers, and I want to point out a few things. Here, x to the 9 over x to the 5 is going to be 9 minus 5, so that's x to the 4th. There's nothing on the bottom for the y's, so the y to the 6 just hangs out there. It stays there. Example 2. 20 divided by 5, like I said, is 4. We can cancel out our x's. X to the 3rd over x to the 3rd is just a 1. And we have, and 1 times 4 is just 4. Y to the 6th over y leaves us with y to the 5th. So our answer is 4y to the 5th. Here, for example 3, 4 divided by negative 2 is going to give us negative 2. Then we have the a. Nothing on the bottom that we can do anything with for the a, so it's just going to hang out here. B to the 9th over b to the 3rd leaves us with 9 minus 3, which is 6. C to the 6th over c to the 5th is just 6 minus 5 is 1, so we have c to the 1, or c. So our answer then becomes negative 2a b to the 6c, and there's nothing more we can do to simplify it. Example 4. Little tricky here. I have an x to the 0. Now that just leaves a 1, or you could say x to the 9 minus 0 is just going to be x to the 9. Y to the 6th over y to the 1 is going to be 6 minus 1, which is 5. Y, x to the 9th, y to the 5th. I hope you got them all right. If you have any further questions, please see me in class.